दोस्तों क्वाइज सक्सेस के यूट्यूब चैनल में आप सबका स्वागत है।
Introduction.
I have to do lots of work. I'm so tired. I don't have any more energy now.
Mom, why do you need energy?
Son, we do lots of work daily. Reading, writing, thinking, cycling, etc. So we need energy to do all these activities.
Mom, this washing machine also does work. Does this also need energy?
Yes, but there's a difference. Come, I will tell you about the work and the energy.
Objectives. At the end of this lesson, you'll be able to define work and energy, write different forms of energy, write the expression for kinetic and potential energy, understand the laws of conservation of energy, define power, write the units of work, energy and power. Work. Friends, we do lots of work like playing, studying, cycling, running, etc. All these works require a lot of energy. But the scientific definition of hard work may involve very little work. Let's see how. Look at this huge truck. We work hard to push it, but the truck does not move despite all the effort. We get tired. However, we have not done any work on the truck as there is no displacement of the truck. We can say that we did hard work, but in science the work is not done on the truck. We use and define the term work differently in science. For example, if we climb up a cliff, then according to science, we have done lots of work. Scientific conception of work. For work to be done, these two conditions should be satisfied. First is, a force should act on an object. Second is, the object must be displaced. Let's take a look at a few situations. If we pull a table and the table moves through a distance, here we have exerted a force on the table and it is displaced. So both the conditions are satisfied here. Therefore, work is done. Similarly, while playing cricket, if we hit a ball with a bat, then work is done because force is exerted on the ball and that ball is displaced. Work done by a constant force. To understand the concept of work in science, let us consider a case. Case is, the force is acting in the direction of displacement. Let a constant force F act on an object. Let the object be displaced through a distance S in the direction of the force. Let W be the work done. We define work to be equal to the product of the force and displacement. Work done is equal to force into displacement, or W is equal to F into S. Thus, work done by force acting on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of the force. Work has only magnitude and no direction. If F is equal to 1N and S is equal to 1M, then the work done by the force will be 1 Nm. The unit of work is Newton meter or joule. Thus, 1 Newton meter or 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. Example. Let's now find the work done when force applied and displacement is given. A student lifts his school bag from the ground and puts it on his shoulders, 1.5 meter above the ground. A force of 5 Newton is acting on an object. Calculate the work done by him on the school bag. We can see that here force applied is 5 Newton and displacement S is 1.5 meter. We know that work done is equal to force into displacement. Therefore, we get work done is equal to 7.5 Newton meter or 7.5 joule. Assessment.
Before proceeding further, let us know how much you have learned. Click the correct option.
Energy. We now know that to do any kind of work, we need energy. We must have energy to accomplish work, but the question is, where does this energy come from? The sun is the biggest natural source of energy to us. Many of our energy sources are derived from the sun. Energy sources are classified into two groups: non-renewable and renewable. Most of our energy comes from non-renewable energy sources: coal, petroleum, natural gas, propane, and uranium are non-renewable energy sources. They are used to make electricity, to heat our homes, to move our cars, and to manufacture all kinds of products. These energy sources are called non-renewable because their supplies are limited. Renewable energy sources include biomass, geothermal energy, hydropower, solar energy, and wind energy. They are called renewable energy sources because they are replenished in a short time. We use renewable energy sources mainly to make electricity. An object having a capability to do work is said to possess energy. The object which does the work loses energy, and the object on which the work is done gains energy. The energy possessed by an object is thus measured in terms of its capacity of doing work. The unit of energy is, therefore, the same as that of work, that is, joule. 1 joule is the energy required to do 1 joule of work. Sometimes a larger unit of energy called kilojoule is used. 1 kilojoule equals 1000 joules. Forms of energy. There are many different forms of energies. These various forms include potential energy, kinetic energy, heat energy, chemical energy, electrical energy, and light energy. Let us first study about kinetic energy. We know that a moving object can do work, and an object moving faster can do more work than an identical object moving relatively slow. Kinetic energy is the energy possessed by an object due to its motion. The kinetic energy of an object increases with its speed. Turning wheel, moving car, boy running are the examples of kinetic energy. So we say that the kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it acquire that velocity. Equation of kinetic energy. Let us now express the kinetic energy of an object in the form of an equation. Consider an object of mass m moving with a uniform velocity u. Let it now be displaced through a distance s when a constant force F acts on it in the direction of its displacement. We know that the work done W is Fs. The work done on the object will cause a change in its velocity. Let its velocity change from u to v. Let a be the acceleration produced. The relation connecting the initial velocity u and final velocity v of an object moving with a uniform acceleration a and the displacement s is v square minus u square equal to 2as. This gives s is equal to v square minus u square whole upon 2a. We know that F is equal to ma, so by using values of F and S in the equation of work, we get W is equal to ma into v square minus u square whole upon 2a. Or we can write it as W is equal to 1 upon 2 into m into v square minus u square. If the object is starting from its stationary position, this is u is equal to 0, then the work done, W is equal to 1 upon 2 into mv square. It is clear that the work done is equal to the change in the kinetic energy of an object. Thus, the kinetic energy possessed by an object of mass m and moving with a uniform velocity v is 1 upon 2 mv square. Example. Let's now find the kinetic energy of an object of mass 10 kg which is moving with a uniform velocity of 4 meter per second. Solution. Here mass of the object m is equal to 10 kilogram. Velocity of the object v is equal to 4 meter per second. From equation of kinetic energy we get 1 upon 2 into 10 kilogram into 4 meter per second into 4 meter per second, which is equal to 80 joules. Hence, the kinetic energy of the object is 80 joules. Potential energy. To understand potential energy, let's do an activity. Take a rubber band. Hold it at one end and pull from the other. You will see that the band stretches. Now release the band at one of the ends. What do you see? The band will tend to regain its original length. This means that the band had acquired energy in its stretched position. Do you know how did it acquire energy when stretched? Here the energy gets stored due to the work done on the object. The energy transferred to an object is stored as potential energy if it is not used to cause a change in the velocity or speed of the object. We transfer energy when we stretch a rubber band. The energy transferred to the band is its potential energy. The potential energy possessed by the object is the energy present in it by virtue of its position or configuration. Potential energy of an object at a height. Gravitational potential energy is the energy stored in an object as the result of its vertical position or height. Let's find out the expression for the gravitational potential energy of an object at a height. Consider an object of mass m. Let it be raised through a height h from the ground. A force is required to do this. The minimum force required to raise the object is equal to the weight of the object. The object gains energy equal to the work done on it. Let the work done on the object against gravity be W. That is, work done, W, is equal to force into displacement, which is equal to mg into h, which is equal to mgh. Since work done on the object is equal to mgh, an energy equal to mgh units is gained by the object. This is the potential energy of the object. Also, the work done by gravity depends on the difference in vertical heights of the initial and final positions of the object and not on the path along which the object is moved. Conversion of energy. Answer one question now. Can we convert energy from one form to another? Yes, one form of energy can be converted into another form. Let's take a small example. When we switch on a bulb, the electric energy is converted into light energy. Similarly, when we plug on the TV, the electric energy converts into heat energy, sound energy, and light energy. Laws of conservation of energy. We now know that the form of energy can be changed from one form to another. Whenever energy gets transformed, the total energy remains unchanged. This is the law of conservation of energy. According to this law, energy can only be converted from one form to another. It can neither be created nor be destroyed. The total energy before and after the transformation remains the same. Let us consider a simple example. Let an object of mass m be made to fall freely from a height h. At the start, the potential energy is mgh and kinetic energy is 0. Why is the kinetic energy 0? It is 0 because its velocity is 0. The total energy of the object is thus mgh. As it falls, its potential energy will change into kinetic energy. If v is the velocity of the object at a given instant, the kinetic energy would be 1 upon 2 mv square. As the fall of the object continues, the potential energy would decrease while the kinetic energy would increase. When the object is about to reach the ground, h is equal to 0 and v will be the highest. Therefore, the kinetic energy would be the largest and potential energy the least. However, the sum of the potential energy and kinetic energy of the object would be the same at all points. That is, potential energy plus kinetic energy is equal to constant, or mgh plus 1 upon 2 mv square is equal to constant. The sum of kinetic energy and potential energy of an object is its total mechanical energy. We find that during the free fall of the object, the decrease in potential energy at any point in its path appears as an equal amount of increase in kinetic energy. There is thus a continual transformation of gravitational potential energy into kinetic energy. Rate of doing work. Consider two children, say A and B. Let us say they are of the same age. Both start swimming separately. Let us say A takes 5 minutes while B takes 9 minutes to accomplish the task. They did the same work, but A has taken less time than B to do the work. This means that a stronger person may do certain work in relatively less time. Similarly, a more powerful vehicle would complete a journey in a shorter time than a less powerful one. So, power is defined as the rate of doing work or the rate of transfer of energy. If an agent does a work W in time t, then power is given by power is equal to work upon time, or P is equal to W upon T. The unit of power is watt, having the symbol W. 1 watt is the power of an agent which does work at the rate of 1 joule per second. We can also say that power is 1 watt when the rate of consumption of energy is 1 joule per second. 1 watt is equal to 1 joule per second. We express larger rates of energy transfer in kilowatts. 1 kilowatt is equal to 1000 watts. 1 kilowatt is 1000 joule per second. Commercial unit of energy. We know the unit of energy is joule, but the large quantities of energy cannot be expressed by the unit joule. For that we use a bigger unit of energy called kilowatt hour. Let us take an example of a machine that uses 1000 joule of energy every second. If this machine is used continuously for 1 hour, it will consume 1 kilowatt hour of energy. Thus, 1 kilowatt hour is the energy used in 1 hour at the rate of 1000 joule per second, or 1 kilowatt. So, 1 kilowatt hour is equal to 1 kilowatt into 1 hour is equal to 1000 watt into 3600 second, which is equal to 36 lakh joule. 1 kilowatt hour is equal to 3.6 into
10 raised to the power
6 joule. The energy used in our houses and big industries are usually expressed in kilowatt hour. Did you know? James Prescott Joule was an outstanding British physicist. He is best known for his research in electricity and thermodynamics. Amongst other things, he formulated a law for the heating effect of electric current. He also verified experimentally the law of conservation of energy and discovered the value of the mechanical equivalent of heat. The unit of energy and work, called joule, is named after him. The potential energy of an object at a height depends on the ground level or the zero level you choose. An object in a given position can have a certain potential energy with respect to one level and different value of potential energy with respect to another level. Summary. Let us summarize what we have learned. Work done on an object is defined as the magnitude of the force multiplied by the distance moved by the object in the direction of the applied force. The unit of work is joule. 1 joule is equal to 1 Newton into 1 meter. An object having capability to do work is said to possess energy. Energy has the same unit as that of work. An object in motion possesses the kinetic energy of the object. An object of mass m moving with velocity v has a kinetic energy of 1 upon 2 mv square. The energy possessed by a body due to its change in position or shape is called the potential energy. The gravitational potential energy of an object of mass m raised through a height h from the Earth's surface is given by mgh. According to the law of conservation of energy, energy can only be transformed from one form to another. It can neither be created nor destroyed. The total energy before and after the transformation always remains constant. The sum of the kinetic and potential energies of an object is called its mechanical energy. Power is defined as the rate of doing work. The SI unit of power is watt. 1 watt is equal to 1 joule per second. The energy used in 1 hour at the rate of 1 kilowatt is called 1 kilowatt hour.
दोस्तों, आपका क्वाइज सक्सेस में स्वागत है। अब बिना समझे रट्टा मारने की कोई जरूरत नहीं। हम लेकर आए हैं पढ़ाई का एक नया तरीका जहां 3D एनिमेटेड वीडियोस, AI पावर टेस्ट सीरीज और ई-बुक्स में MCQs और माइंड मैप्स का परफेक्ट कॉम्बिनेशन मिलता है। क्लास 8 से 10 के स्टूडेंट्स के लिए फाउंडेशन कोर्स और क्लास 11 और 12 के स्टूडेंट्स के लिए सक्सेस ब्लूप्रिंट कोर्स, ये सब IIT और IIM अलुमनी के सहयोग से तैयार किया गया है ताकि आपको मिले सबसे भरोसेमंद और रियल एग्जाम एक्सपीरियंस के साथ कॉन्फिडेंस बूस्ट। चाहे इंजीनियरिंग एंट्रेंस हो, मेडिकल एंट्रेंस हो या कोई भी कम्पिटिटिव एग्जाम, अब सक्सेस आपकी मुट्ठी में है। हजारों स्टूडेंट्स पहले ही जुड़ चुके हैं, अब आपकी बारी है। पढ़ो अपने घर से, अपने समय के अनुसार, अपनी सुविधा से। बस QR कोड स्कैन करो और क्वाइज सक्सेस मोबाइल ऐप अभी मुफ्त में डाउनलोड करो। मॉक टेस्ट्स दो, प्रैक्टिस करो और अपने मार्क्स में फर्क देखो। और हाँ, हमारे YouTube चैनल क्वाइज सक्सेस पर रोज देखो नए वीडियो कोर्सेज के लिए। चैनल को सब्सक्राइब करो और अपने दोस्तों को भी जरूर बताओ। धन्यवाद।